Alright, gentlemen, I understand there's been some trouble with the can homework, the crushing can homework, so I'm going to try to walk you through the problem a little bit. So the first thing is we have this can that looks like a cylinder. And what I'm going to do with this cylinder, because I'm concerned about the surface area, since we all know that pressure is force over area, and we're trying to find the force it can withstand, we need to know something about the area. So instead of trying to figure out the area of the cylinder, what I'm going to do is take tin snips, cut a line down here, break the top and bottom off. So I'm going to have a top part of my can. That's from here. I have the bottom part of my can right here. And then this center part, I'm going to kind of unravel. So you can imagine like this big sheet like this. Right? And if we roll that out, stretch it, roll it out flat, it'll look like a big rectangle. So now my area is the top and the bottom and this rectangle. Now we all know the area of a rectangle is just length times width, but in this case, what do we mean by length and width? Well, this line is really the height of the cylinder, so we could say, call this really h. The length, this line, is really the outline of the top, which used to be a circle. So we could call that the circumference of the circle, which is going to be equal to 2 pi r. So length times height will give us the area of this piece. The area of the top and bottom, since they're both circles, is each going to be pi r squared. So if we add all that up, we get a total area. So I know this. Now we have to worry about pressure. Well, where's the pressure coming from to crush all of your cans? Well, it's coming from the air around it. So if you take, whether it's the train tanker or the 55-gallon drum or the paint can, let's pretend that all of the air is out of this. Now for the train tanker, the air was sucked out with a vacuum. For the paint can and for the 55-gallon drum, this barrel was open. It was heated to very, very, very hot temperatures. And when you have very, very, very hot temperatures, all that gas wants to expand. It starts going out the top. Then they sealed it, took it away from the heat, cooled it down. As that temperature went down, it was sealed. So no molecules came in or went out. R is constant, that stayed the same. The size of the drum remained the same. So what happened was, when the temperature went down, the pressure also went way down. Now let's just assume there's zero pressure inside the can, which means you have air pushing on it from the side, from the top, from the bottom, but nothing pushing back. So this can is in static equilibrium now because of the strength of the steel, but eventually it cracks. Once it cools down enough and the pressure really goes away to nothing, it gets squished. So we can say the pressure that squished it is really 1 atmosphere, 1 atm, which is 1.01 times 10 to the 5th pascals. So we know our pressure, we know our area, we can find the force. And that's it. I will see you guys on Monday. I hope you make good use of tomorrow and the weekend.